Good answer. Measures of position, the last kind of measure. So we have z-scores, and z-scores will be used a lot. So z-score is used to measure the location of a data point with respect to that data set's mean and standard deviation. So z-score is how many standard deviations above or below the mean that data point happens to be. This also allows us to compare data points from two different sets. So, for instance, we can go ahead and say, okay, well, here's the average and standard deviation for the SATs, average and standard deviation for the ACTs. You're given two scores, one for the SAT, one for the ACT, and you're asked, relatively speaking, which one was better. You can use z-scores for that. Higher z-score would be the better. Right, so z-score doesn't matter whether it's population or sample. It's measured the same way. It's just, are you using a statistic or a parameter? It's always the data point minus the mean divided by the standard deviation. A positive z-score obviously means that you're located above the mean. Negative z-score is you're below the mean. If you look at the z-scores, so convert every single data point into a z-score and use that as your new data set. It will have a mean of 0 and standard deviation of 1. The z-score of the mean is obviously 0. Next up, percentiles. Probably familiar with percentiles. It's used a lot. They indicate percent of values in a data set below a specific value. And I believe if you take the SATs, when they give you their score, I believe they also give you the percentile that you scored within. That's what they gave, right? So if they say, oh, this fell within the 60th percentile, that means 60% scored worse than you. Which also happens to mean 40% scored better. And if you have children, take them in for their checkups. It's what, every month for the first 6 or something. That's like every 3, and then every year or something like that. They do their weight, their height, and then you tell you the percentile they fall in. Someone was at least, I think he was in the 95th or above. My daughter would have been these too, but she was like 4 months premature.
You did this with your kids?
They said if she would have been full term, she would have been like 10 pounds.
Full
Son was
life?
only 8.
Of yours, because that's a huge baby.
Oh yeah, I know. But she decided she didn't want to stay in any longer. She chose when to come out.
There's more space for her. At 8 pounds?
No, that was an indication of how her temperament would be. Percentiles are typically denoted as piece of K, so that would be the K percentile. 50th percentile is the median. Special collection of percentiles. 25th, 50th, 75th. These are your quartiles. And in fact, there was also 2 other values of particular note. The 0th percentile and the 100th percentile. What do you think the 0th percentile is?
You're the worst.
So if you have a set of data points, how would you determine the 0th percentile? What data point is it?
The lowest one.
The minimum, right? What's the 100th percentile?
The highest.
The maximum. All of those percentiles together, so you have your min, your max, and then the 3 quartiles are the 5-number summary. We typically just represent that as min, Q1, median, or med, Q2, and max. Well, this gives us something new to calculate. The difference between Q3 and Q1, called your interquartile range. With the 5-number summary and the IQR, we can now more precisely define what we mean by an outlier. Right, so we've already discussed outliers of value considerably larger or smaller than the rest of the data set, right? So again, it's all relative. To determine outliers, we first have fences. These fences are the cutoffs. Right, so you have a lower fence and an upper fence. Lower fence would just be the lowest value you would expect in your data set. Upper fence is the largest value you would expect. And then anything outside of those fences is an outlier. Lower fence is Q1 minus 1.5 times IQR. Upper fence is Q3 plus 1.5 times IQR. Now, for purposes of this course, we also consider extreme outliers with what the author terms as an upper fence and a lower fence. I can tell you, with all my work in statistics and research, we don't ever use those. It's just the upper and the lower.
So why learn it? For fun?
Because the course coordinator decided it.
But like you wrote stats here, and that's not like the thing.
I'm not saying it's not a thing, it's just we never use it. I'll say teaching this course was the first time I heard of those.
What is it called? I'm sorry? That just makes three words.
The upper and lower fences. They're never used, or at least I've never used them. And I also took grad stat courses. So take it for what it is.
So when are we going to need to learn it?
The
So
only,
that's my
well,
question.
again, for this course, you're going to need to. But outside of this, I don't know how often you're going to use them. I mean, it's possible maybe you run into a case where you want to delete outliers, but only the extreme ones, and then maybe you use this. But again, in my fields, we've never just eliminated outliers. The only difference between the two is what you're multiplying the IQR by. And it's now 3 instead of 1.5. Again, anything lower than the lower fence is an outlier, and anything above the upper fence is also an outlier. Now we get to do our first graph. So in statistics, it's generally better to visualize your data for the general public. Right, because pictures draw eyes. The first representation we're going to use is called a modified box plot, or just simply a box plot. Box plots use the 5-number summary along with outliers. So what we're going to do is first draw lines at Q1, the median, and Q3. And then using Q1 and Q3 as your edges, you draw a box. And so you just connect Q1 and Q3 with horizontal lines. Now, I personally do this step last. But you'll draw asterisks at your outliers. Or, depending on the software you use, I think Excel uses just dots. Then you draw what are called the whiskers. Your lower whisker is going to go out to the minimum value. Upper whisker goes out to the maximum value. Another name for box plot is a box and whisker plot. You may also see that. They're all the same. I guess I should specify, when I say maximum and minimum, I'm referring to non-outliers. starting with finding z-scores. Oh boy, are we going to be doing this a lot later. Right, we're given a certain data set from a population. It has a mean of 45 and a standard deviation of 4. The z-score associated with the data point 52. So I also typically, from just calculating the z-scores, will use a subscript to represent the data point. I could probably also just do this. Represent z-score of 52. Doesn't matter, it's just symbology. Your data point minus the mean all over your standard deviation. Mean was 45. Standard deviation is 4. That's 7 over 4. Which is 1.75. And as a general rule of thumb, z-scores are 2 decimal places. At a more advanced level, we'll go out further. But for now, keep z-scores to 2 decimal places. When we look at it, we go, well, it's positive, and 52 is above the mean. So good. That makes sense. It'd be bad if we got a negative. Next up, z-score for 32. It's your data point minus mean divided by standard deviation. Negative 13 over 4. Which is negative 3.25. Now we go the other way. We're given that the z-score is negative 2.25. What's the associated data point? Do a little bit of a derivation. In that formula, you want to solve for x. Sigma times z plus mu would be your data point. Four times negative 2.25 plus 45. Four times 2.25 is 9. And then negative 9 plus 45 would be 36. There's your data point. Okay. So this one you have to decide to give me 1.87. Let's see if we can do this. 4 times 87. 4 times 80 is 320. Times 7, 28. So that's 348. So it'd be 3.48. How's that? 4.48. I'm sorry. 7.48. And that'll be 52.48. Again, just check, make sure they make sense. Negative z-score, 36. That is definitely less than the mean, so that's good. Positive z-score, we got 52.48, which is larger than the mean. So that's good. This is a sample. I think what I might do is skip ahead for now. The sample's done the exact same way as population. Oh, look at that. SAT. Yeah. SAT score. So the SAT scores have a mean of a 1059. When that's taken, that's a garbage score. SAT scores were out of 2,400 lines. 3 settings, 3 sections: math, reading, and writing. Each worth 800. If it's just out of the 2, then I guess a 1059 is a 10. Standard deviation of 210. ACT scores have a mean of 20.6. A standard deviation of 5.8. Relative to the test, is a 1250 on the SAT or a 28 on the ACT better? Which one of those is better? All right. This is where we have to go to z-scores. Z-scores give us a way of standardizing your data set. For the SAT, the data point one's 1250. Mean of SAT scores is 1059. Standard deviation, 210. $12.50 minus $10.59, 191. Can I do that right? Should be. 191 out of 210. Way too lazy to do that. Less than 1. .9095238, so on and so forth, so we'll just say 0.91. ACT scores 28. Average was at 20.6 with a standard deviation of 5.8. That's going to be what, 7.4? Without going any further, I already know the ACT's better. That's going to be larger than 1. .27586 on the surface, let's just say 1.28. Right, so since the 1.28 is larger than that 0.91, .28 on the ACT is better than 1250 on the SAT. So, certain county has 150,000 homes. We have the 15th percentile is $120,000. 50th percentile is $175,000. 65th is $210,000, and the 90th is $255,000. So I don't know either when this data was taken, but what county that is. The median home price is $175,000. Something up. I think the median home price in New Jersey is like $300,000. And that's for a shack in the woods. What percentage of values are below 120? Oh, that shouldn't be too difficult. 15%. What percentage are between 120 and 210,000? Well, if we know that 65% is less than 210, and 15% is less than 120, should be the difference, right? Kind of works like a simple area problem. 65 minus 15 is 50%. What percentage of values are above 210,000? Well, 65% less than. 35% would be larger than, right? $100 minus 65. And what percentage of values are above 120? Same argument. $100 minus 15, 85%. And what is the median assessed value? $175,000. Right, it's the 50th percentile. So given this data set, we want a box plot. Which means we don't really need 5-number summary. Not really, but we'll find it. So I'm going to do most of this work on a different slide. The two easiest ones to find are the minimum and the maximum, especially if the data set is already ordered for us, which it is. And if it's not, then you hope it's already in Excel, so you can just have Excel order it for you. Minimum's 14, maximum is 85. Right, now I'm looking at that. There is a high likelihood that both 14 and 85 are outliers. You kind of tell just by looking at the data set. Most of them are congregated right around 40s and 50s. But until I do the calculation, I don't know for certain. I'm more confident in 14 than 85. 90% 14 and 70% 85. The next easiest one is the median. How many data points do we have? Oh, I thought it was 12. So that's an average of the middle two, right? with the average of 47 and 53. So I'm just going to write that way. So how do you find that average? How'd you get it?
You have the 700 divided
50. Q1. It doesn't appear like we want to use the actual formulas, which I guess is good. The answer that we're going to get here is going to be different. I guarantee it. It's going to be different than what Excel would give you. There is a formula to find percentiles. It doesn't appear like we're actually using them, so that's good. What I'm going to do is divide this in half. Q1 is the median of the smaller data set. And there's 6 in each. So Q1 is the average of 38 and 43. Which is what?
4.5.
Average of 55 and 56. Oh, it's an easy one. $55.5. Okay, so here's how I'm going to start. Q1 was 40.5. Maybe right there. Of course, I have to have straight lines, so I'm just going to use ruler. Maybe right there looks like 48 and a half. Median was 50. And Q3 was 55 and a half. 55, something like that. And I can always extend those out if I need to. Now I'm going to draw my box. enough government work. I now need what are called the whiskers, and these are just horizontal lines. But they're only going to go out to the minimum non-outlier and the maximum non-outlier. Well, chances are 14 is not the minimum non-outlier, but we don't know that. So let's determine. Compute the IQR. Q3 minus Q1. 55.5 minus 40.5. Oh, that's good. So we can essentially just treat that as what? 40 minus 55, or 55 minus 40, which is 15. Lower fence. Q1 minus 1.5 times 15. Half of 15 is 7.5. Add that to 15, 22.5. It's 40 minus, or 40.5 minus 22.5, so just 40 minus 22, which is what, 18? Upper fence is Q3 minus the same thing, 1.5. 55 minus 22, 33? No, that can't be right. Oh, I'm sorry, it's not minus, that's why. It's plus. 55 plus 22 is 77. But then you have the half plus a half, which is 1, so it's 78. Okay. And we stop opening other things up. Thank you. So here's what I'm going to do with the data. Lower fence of 18, anything less than 18 is an outlier. Kind of cross off the 14. And over here, probably 14 right there. So for right now, I'll just mark it. That's the only one less than 18. And then we said 78 was the upper fence. So just cross out that 85 and then draw an asterisk at 85. Those are the outliers. There's my min and my max. 34 and 58. That's why 34 right there. $58, probably right there. And generally what you want to do is draw the whiskers from the middle. Is that asterisk in line? Where's the asterisk in line? No. Maybe not. one's good enough. Okay. There you go. There's our box-and-whisker plot. Two ways you can draw it. You can either draw it horizontally like we did here, or vertically. And Excel gives vertical. Actually, I like the horizontal better. And so again now, let's say that we're actually in the workforce. We're not going to be using 12 data points, right? It's going to be a lot more than that. This is the same data set as we used last time. Data, I think it was this one here, right? From text, yes. And we're going to go and find our data set, which I did upload. That one there. Yes. Based on, of course not, based on entire data set. I think I showed this one last time. It should give me a table. Yeah, got it. Don't care about colors. And zoom that all the way down. And again, I'm only focusing on magnitudes. So I'm going to go ahead and hide. I think it wants to do the box plot, but it also wants to kind of do all the work with it as well. So first, we're going to use this to find the 5-number summary, as well as the fences. It's here. It up. It's here. Merge and center. I'm going to merge those two cells. A little bit larger, and then let's call this the min. Remember, it was min, and then your array. How many was there again? That was a lot. Down to 2499. E2 to E2499. There's our min. Q1. Maximum. There's the max. Okay. Let me try to remember what it was. So quartile dot INC. We need the array. And what quartile do you want first? Got 4.2. Well, median was easy, right? That's just the median. But what I also want to do is, let's see. If I use the quartile formula. Oh, good, it does give me the exact same thing, so that's nice. And now I want the third. There's our 5-number summary. I'm also fairly certain if you install the data extension, no, it's not data, it's data analysis, which I don't have on here. I used to. What happened to it? Oh, it's right there, data analysis. It doesn't show you, but there's a lot of stuff in here that we can use, and I'll probably be using it throughout the semester, so I'll show it off then. But there is a option to do descriptive statistics, which gives you the 5-number summary along with a lot of other information. I want the IQR, right? Because now I have to find my fences. Equals. It was Q3, right? Which I have as Z6 minus Q1, which is Z4. You could also just click those cells, enter. Lower fence was Q1. All right, so notice now once I hit equals, I can just click cells to reference them. Minus 1.5 times IQR. Upper fence Q3 plus 1.5 times IQR. There's the upper and the lower fences. However, I'm not interested in trying to determine my outliers from this because there are a lot of data points that I do not want to go through. I could sort them, but that's still way too many that I don't want to go through. So I'm not going to make you list out the outliers here. That's done. Now, let's insert the box plot. Insert. Over here in charts. It should be statistical. It should be, no, that's Scouter. Statistical chart. Right, so this bar one that's right in the middle. It's not showing that drop down, is it? I'm going to have to share my screen. That is annoying. Brings a drop down, box and whisker. There's only one. I'll do that, and then I'll adjust everything. Show it. That's what we want. select data. Okay. Yeah, that's share. All right, so if you right click, I want to select data. I'm just going to go ahead and why is it giving me those? I think if I maybe do this, change data range, I just want E2 to E2499. Perfect. Okay. That's what it gives us, which looks terrible. I'm going to adjust the axes. Should be able to do that just by double clicking. That's major grid lines. Oh, I think I have to actually click this here. Double click that, there it is. I can now choose my own minimum and maximum. I don't have to worry about this starting at 0. We'll discuss the implications of not starting at 0 with misleading graphs. Boxplot, yeah, that's not one of those. Our minimum was 2.45, so let me just start at 2. Maximum is 8.8, so I don't know, let's say it's 9. That definitely looks better. Now, I double click that. I want to get rid of the inner points. Show only outlier points. Let's get rid of the mean markers too. But let's show the mean line. And let's do an inclusive median, not exclusive. There we go. And as far as I'm aware, there's no way to make that horizontal. I looked into it, and I could not find an answer, which is sad. I can still adjust up here, like design. I can change colors. I tend to just be boring. And also just adjust it more here. Yeah. So I made the lines a little bit lighter so that's more easy to see, the median line. I could do no fill. I think that's probably the best bet. No fill, make it a solid line, and make the line color black. That's probably the best view, right there. Can I change the points in any way? I don't think I can change those point options. I can, I'm not aware of it. Maybe with the layouts. I can probably do it with one of these layouts, but I'm not that worried about it. I'll let you mess around with them. Right on the, what do we call this? Magnitudes one. And there's a box plot. Right, so that's using Excel to do all that for you. So, first assignment, we're going to use AI. I gave you a data set. Chances are you're going to have to download that data set so you can upload it into the AI. And I believe it's going to ask you to have AI calculate several values for you from that data set, and then you'll have to verify them. And then obviously compare, and then just going to get a reflection on how useful generative AI is becoming. I've never actually used it for stats. I've never actually uploaded a data set and asked it to do any kind of statistical analysis on it, so I don't know how it's going to behave. However, I have used it for differential equations at the highest. That was the highest level math quiz I've used it for, and it's really good. If you prompt it right, I got about a 90% accuracy. So I would assume it's probably going to be really good for this. Oh, mind you, that was with GPT-4. It's now up to GPT-5. Right, but this is going to get you used to using AI because I guarantee you in your field you're going to have to use it. Know how to prompt it. Plus it might save you time. All right, so that's going to be due 1 week from today. So due before next Tuesday's class. And then obviously the extra credit homework assignments D&E will be due by the end of Monday. So what we'll do now is rest of the class. Just work on the worksheet. And then these will be posted as well. So go ahead and get into your groups.